So hello everyone, welcome to my channel Learn with RP Sir Mtech JU. My name is Rahul Paul and today we are going to discuss integration by partial fractions, another application question, and this question will be based on two type of denominators. One is linear distinct denominator like the linear distinct factor. Another one is non-reducible quadratic expression. Okay, now what are these things? If you are not getting, you have to watch my theory video where I have discussed each and every category of partial fraction and how to deal with them, like a framework I have already discussed. So if you haven't watched that, please go and watch it, and then it will be much easier for you to understand every step of what I'm going to do in this question. Okay, so let's get started with this particular question. Okay, so as you can see, this is the question over here, and we have to find out the answer of this integration. And also, as you can see, this is a linear distinct factor and this is a quadratic equation which cannot be reduced to a linear factor, meaning you cannot factorize this quadratic expression. So now what to do with this type? Let us start. So first we are going to write the framework of the partial fraction, how we are going to break it into partial fractions. Let us understand. So we have x square plus x plus 1 over x plus 2 times of x square plus 1. So now if I do the breaking, so it will be a over x plus 2 plus bx plus c over x square plus 1. So this is how we break the non-reducible quadratic expression. I've already demonstrated in theory, so please go and watch that first. Okay, it's a request because otherwise you won't be able to get the steps clearly. Okay, so you have to watch that particular video and then you will be absolutely clear with what I'm going to do in this question. So now once we have done this, now we have to combine the denominators. So x square plus x plus 1 over x plus 2 times of x square plus 1, and here we are getting again x plus 2 times of x square plus 1. I'm making the denominators the same. So what is the numerator now? A times of x square plus 1 plus bx plus c times of x plus 2. Okay, so this is the next step. And now final step on the framework, x square plus x plus 1 will be equal to a times of x square plus 1 plus bx plus c times of x plus 2. Okay, so this is the total framework. Now we are going to find answers of the constants a, b and c. Okay, there are three constants a, b and c. We are going to put different values of x and we are going to find out the value of a, b and c. So let us understand how to do it. Now as you can see, bx plus c is multiplied with x plus 2. Now if I put x equal to minus 2, so this factor becomes 0, and anything multiplied with 0 is also 0, which means bx plus c is equals to 0, which means b and c both shall be eliminated. I'm not saying that they are 0, they will be eliminated for the moment. Why? Because we cannot solve an equation with three like constants just in one step, right? We have to make sure the other constants get eliminated. So this is a very important step which will directly get me the value of a. So let's find out. So if I put x equal to negative 2, so if I put x equal to negative 2, so it will be 2 square plus 2, sorry, 2 square, it will be negative 2 square, my bad, negative 2 square plus negative 2 plus 1 on this side, and on this side a times negative 2 whole square plus 1. That's it. The others will be eliminated. So now 2 square is 4 minus 2 plus 1. So 5 minus 2, 3. And here we are getting 4a. Sorry, 5a. 2 square itself is 4. So 5a. So from here we are getting the value of a is equal to 3 over 5. So that is the first case. A is 3 over 5. Okay. Now we have to find the value of B and C. Now I cannot find a way to eliminate a, that is because it's x square. If I put x equals to negative 1, still because of the square it will become positive 1. And also besides there are two constants in a single bracket. So the only way I can possibly think of putting one constant out of the picture if I put x equal to 0. Now think about it. If you put x equal to 0, the b is multiplied to a 0. That means b is eliminated. So now if I put x equal to 0, that should be my second step. If I put x equal to 0, so this particular part gives you 1 because everything else will be 0. 0 square, 0, everything is 0. Here it's a times of 0 plus 1. So basically a times of 1. So basically a in a is 3 over 5 plus. Now after this bx plus c, x is 0, so b is eliminated. C times of 2, 2c. So now we have got another variable, another constant, which we will get the answer. So 2c is equal to 1 minus 3 by 5, which is 2 by 5. So c is equal to 1 by 5. The value of c is equal to 1 by 5. And finally, to get the value of b, you have to take any random value because none of the constants will get eliminated. So if I put x equal to 1, so what are we getting here? So 1 square plus 1 basically 3, and this is 3 by 5 times 2, so this is 6 by 5, and this is b times 1, so b plus 1 by 5, which is c, times of 1 plus 2, that is 3. So from here we can write 3 minus 6 over 5, that is equal to 3b plus 3 over 5. So from here this is 15 minus 6, so 9 over 5, and minus 3 over 5, so again 6 over 5, and that is equal to 3b. So b is equal to 6 over 5 over 3, which is 2 over 5. So we have got at the end a is equal to 3 over 5, b is equal to 2 over 5, and c is equal to 1 over 5. Three constants are hence found. Now this is one of the major steps that we have already covered. Now we will have to break it down in this format and try to solve this one. So integration x square plus x plus 1 over x plus 2 times of x square plus 1 dx. This can be given as, the constants will stay outside the integration because constants don't participate. So it will be a integration dx over x plus 2 plus b integration x dx over x square plus 1 plus c integration dx over x square plus 1. Okay. Sorry. So next, a is 3 by 5 and integration dx by x plus 2 is logarithm of x plus 2. Okay, plus b is 2 by 5. Now integration x dx by x square plus 1. So in order to do that, why don't I take the 2 inside and make it 2x dx over x square plus 1. Now why have I done so? I'll explain in a while. Let us complete this first. C is 1 by 5 integration dx over x square plus 1. This is clearly the form of 1 by a tan inverse x by a, where a is 1 here. So it will be tan inverse x over 1. Okay, and plus c at the end. Now this part, see, 2x is the derivative of x square. So if I take x square as t, then 2x dx becomes dt, right? And like that, we can do it as dt over t plus 1, which is logarithm of t plus 1, which is nothing but logarithm of x square plus 1. So we can write 3 over 5 logarithm of x plus 2 plus 1 over 5 logarithm of t plus 1. Here t means x square only, so x square plus 1 plus 1 over 5 tan inverse x plus c. Okay, so this is the final answer of the problem. Okay, I hope the total question was clear to you. We started by solving the expression for the partial fraction, the equation for the partial fraction. Then we took random values of x to find the value of the constants a, b and c. Finally, we have changed this format into the partial fraction format and we got the answer as this. So if this particular question is clear to you, please don't forget to subscribe the channel and also to hit the bell icon so that you can get all kind of video notifications with every video that I make in future. And also, very important, if you have any kind of queries in this, please do write me in my contact number that is there in the particular what is called in the description, or you can drop down the comments. I would request you to drop down the comments. That is even better because the number is always busy. It becomes difficult for me to attend so many requests at a time. So if I see the comment while making the video, I'll immediately work on that as well, right? So it will be much more easier for me if you can comment below. So with this note, I'll say goodbye for this particular video. On the next video, we are going to discuss another question related to partial fraction. There is one more question which I wanted to discuss with you because this question is a little bit unique compared to the partial fraction questions, and hence it's important for me to discuss this. So I'll see you again, and until then, take care and have a nice day.